Alright. So boleh nampak tak notebook ni? Class notebook on your Teams. Boleh nampak tak?
Nampak.
Boleh.
Okay, boleh nampak. Boleh nampak dan boleh conteng Alright. So, okay. So, insyaAllah we'll start now. Alright. Okay. So, tutorial 7, the first question is you need to draw a complete PNID and block diagram for this control strategy. So, if you refer to the question, we have two types of the control strategy, which is the first one is the level controller, and the second one is to control the bottom temperature in the column at a desired value. Alright, so PNID, basically PNID diagram we have drawn in past, I don't know, 4 to 5 weeks. So dah masuk pun dalam dalam test and quiz. So could someone help me to draw for control objective, first control objective, which is the level control. So anyone, can you draw me a control strategy for level controller? We have flow, the distillation showing that the initial flow and temperature inlet as shown by Fi and Ti, and then the outlet of the distillation column shown as F1 T1, and it has a steam to help increase the temperature or increase the temperature of the bottom distillation column. So how do we control a level controller? Can someone help to draw the PNID diagram? So basically in control we have a loop, a control loop, which is the first one is the apa dia? In order to detect the level, we need a what? Level apa?
Transmitter.
Yes, level transmitter. So where did we place our level transmitter? Dekat mana kita letak kita punya level transmitter? Dekat mana? Dekat mana? Tank. Alright. Dekat column sebab kita nak measure the level column. So this is the first loop. Okay, first loop is to measure the level transmitter. Alright, we need to measure the level of the column because the objective of this controller is to keep the level in the column at desired value. Alright, so the second loop after the transmission, what do we need in feedback controller? What do we have? The signal, and the signal will be transmitted to the
level controller.
Yes, level controller. So level controller. Kenapa saya lukis dot dot dot? Sebab refer balik to the standard in drawing PNID. Alright, so level will transmit its signal to the level controller. Alright, so level controller. So what is the function of the level controller? Dia dah dapat signal daripada transmitter, so apa dia buat? What is the function of level controller? To make
maintain the level.
Not to maintain. The function is, the keyword is brain. What is our brain do? Apa dia buat?
But decision.
Yes.
To control the level.
Yes, decision. The action is not taken yet. In the controller, the decision is being made. Sama ada nak increase, nak open or to open or to switch off the kita punya finite control element. So basically in a controller, the decision will be made. Okay, so lepas decision dah buat, katalah kita kena buka the valve of the outlet in order to reduce the level of the column, because the level of the column has been increased way from the desired value. So where is the information being fed to? So lepas controller masuk dalam loop apa?
IP.
Okay, IP is basically apa dia function IP ni sebenarnya? Basically IP ni kita akan convert the signal from the controller from electric signal to the pneumatic, sebab valve hanya akan terima pneumatic signal. Okay, so we need transformer basically to convert the signal electrical signal from the controller received by the controller sorry to convert the electric signal to the pneumatic signal. Alright, so and then after this, where the information being sent to? Controller dah buat decision. Okay, kemudian dia akan hantar ke finite control element, which is in our case here is control valve. So this is your action being taken. So start from here. This one is detection. Lepas detection is action. Lepas action is decision. Lepas decision is action. That's how we complete the PNID diagram for level controller. Right? So kita dah solve satu ni. Control objective is to keep the level of the column at the desired value. How about the second one? Can someone help me to draw PNID for bottom diagram? For temperature controller. So the key here is what is the manipulated variable for the temperature controller. Okay, what is the manipulated variable? What happens if the temperature decrease? What should we supply? We should supply apa in the column in order to increase the temperature?
Steam.
Yes, steam. So steam would be your manipulated variable. And then what is your disturbance in this case? What is the disturbance? How do you identify the disturbance of the temperature controller? So when we set a variable of the disturbance, the manipulated variable, and then what others, the set point, you need to mention the variable. Okay, so variable, what is the variable? Variable either flow, either temperature, either level, what else? Level, and then composition, that is the variable. So you need to identify the variable. So if I say what is the manipulated variable of the temperature controller, so it could be the flow rate of the steam. Okay, flow rate of the steam. You need to mention the flow rate, and then and then you can identify, then you can state what is the flow rate of apa? Flow rate of the outlet ke, flow rate of the steam ke, flow rate of the condensate ke. But first you need to identify, you need to state the variable. And the disturbance of the temperature controller in this case is the temperature of the inlet. It can be the temperature of the inlet, and it can be a flow rate of the inlet to the distillation column. So how do we draw a PNID diagram? Macam ni kita buat untuk temperature controller. So same goes to the level controller. We need to measure the signal. So in order to measure the signal, we need the transmitter. So where do we place transmitter for the temperature controller? Kat mana kita nak letak?
Steam punya streamline.
Steam, kita nak measure steam punya streamline ke atau kita nak measure temperature column? Kita nak measure temperature mana? Temperature steam ke atau temperature column?
Column.
Yes, column. So start from here. Okay. So this is your level transmitter. So level temperature. Temperature transmitter. Alright. So temperature transmitter will send its information to the
controller.
Yes, controller. So what is the name of the controller? It is the
Temperature control.
yes, temperature controller. TC referring to the temperature controller. Alright. Okay. After decision has been made, for example, the temperature is below its set point. So decision has been made, and then temperature controller will send the information to the control valve. Okay, before control valve, because the signal received by the temperature controller is in current, so we change to pneumatic. And then the control valve will be, sorry kat sini sepatutnya. Ini lain dia. Okay. The control valve will regulate the valve whether to open in order to increase the flow rate so that the steam will be fed to the column in order to increase the temperature to its set point. Okay, so this two is showing to you on how to draw a complete PNID diagram for above control objective. So we in this tutorial we have two control objective, which is first one is to control the level at its desired value, and also, which require a level controller, and also the second one is to control the bottom temperature at set point. So we need the temperature controller in order to control the temperature at the bottom distillation column. Alright, we move to the second question, which is the question asks you to draw a block diagram for this control strategy. Okay, so block diagram for both controller. We have temperature controller and also the level controller. For this tutorial, you are not required, or you're not asked to calculate all those gain, all those temperature constant, and also all those temperature delay that might be required for certain for certain block diagram information. So can you show me what is the loop of the block diagram? Boleh tunjuk tak dekat saya? Sekejap. Saya balik. Alright, so what is the element in a block diagram? So basically, we transferred back. We transferred back the information from the above feedback controller into a block diagram. Alright, so detail has been given as follows. So it will consist, the block diagram will consist of the transmitter element, controller element, valve, process, and also a disturbance. So, alright, I show you the the block diagram. The block diagram loop. Alright, for example, we try to solve for level controller first. Right, so block diagram consists of starting from we have the output, and also we have the input. So our input will be going to be your set point. So set point. So in this case is level. All right. Okay, so kita ada input, kita ada output. This is the feedback controller. So basically all the direction will be in a loop. All right, closed loop. All right, so we have input and output. So then what is the first element of the controller? Kita ada apa?
Transmitter.
Yes, transmitter. So transmitter, okay, so the information will be sent to the transmitter. Sekejap. So lukislah block diagram untuk transmitter. Okay. Okay, ni untuk transmitter block diagram. After the transmitter will send to the okay, this is the summation. So for feedback, we receive the information from the set point, and then so basically the controller will measure the error. We try to reduce error as reduced as possible, whereby the error approaching zero is better, because in a feedback controller, so for example, this is the height of the output minus height of the set point. Alright, so input we try to get as smallest as possible. Kalau dapat zero lagi baguslah, tapi it is impossible to get zero error in any design of the controller. Alright, okay, and then the information will be sent to the okay, ni block indicate dia apa? Block diagram indicate di untuk block diagram ni untuk apa? Ha? Untuk?
Controller.
Yes, controller. Lepas controller, where the information will be sent to. Masuk mana? Block ni referring to the
Process variable.
yes, process variable, where we need the transfer function in order to put in this block. So this is the process, and then it will send the information to the, lepas dah buat decision, kita dah analyze the process punya transfer function, kita transfer to the apa function block diagram ini? Apa dia? This is for the valve. Alright, so you need to transfer the information to the valve. Saya rasa terbalik lah. This is the controller, valve, then only process. Ya Allah. Kenapa dia macam tu? Sekejap. So the controller send the information to the valve, and then only you can get the process. And then there is a block for this turbine. Okay. So this is the common block diagram for the level controller. So we'll start to fill in the information into the block diagram. Alright, so for transmitter, we need to plug in the information of the, kita tengok transmitter. So transmitter for the level controller. Alright, the level controller. Receive a signal from a level transmitter with a gain of 33.37 TO per cubic meter per hour. So we need to write down the transmitter gain here, 33.3. Okay, so the unit of the gain you need to put it in the stream. So here is the unit. The unit tadi apa? Percent TO cubic meter. Alright. Okay, so after that, this is the set point. And then controller. So we move to the controller. So level controller, the information given is the level controller is the PI controller with a gain of 3% CO over percent TO, and the integral time is 5 seconds. So what is the integral time? What is the symbol of the integral time? T? T apa? T? I. Okay, so since they said that the controller output, this you may refer back to the feedback controller and process dynamic behavior. So feedback controller, so the general term for the level controller is, so for PI controller, the general term is apa dia? KE. Saya terbalik, sorry, ini proses. KC. Betul. Astagfirullahaladzim. Alright. So PI controller is KC times 1 plus 1 over TI time S. Alright. So this is the general term for the PI controller. Okay, so we have the information. The information is the gain. KC is gain. So 3, 1 plus 1 over. So what is the integral time? TI. 5 seconds. Alright. So 5 times S. S is not referring to the second. S is referring to the Laplace transform information. Laplace transform term. Laplace transform term for PI. Okay. So this is the the transfer function that you need to put in the PI controller. So 3, 1 plus 1 divided by 5s. Okay, so then move to the valve. Okay, so valve apa information yang dia bagi untuk level controller? Alright, untuk valve represented by the first order transfer function with a gain of 3 kg per hour percent CO, and the time constant is 2 seconds. Alright, so how do we write down the transfer function for the valve?
KV.
Apa dia?
KV over
Okay. KV KB over?
Time plus 1.
Yes. Alright. So kalau kita tulis dekat sini, the transfer function for the valve is the gain 3 divided by berapa? The time given is?
2.
Yes, 2s plus 1 because this is the first order transfer function for the valve. Okay, tulis balik dekat bawah ni. 3 divided by 2s plus 1. Okay, so lepas masuk valve, masuk ke process. So process the information given for a level controller. Alright, the gain is gain is 1 meter kg per hour. Time constant is 9.6 second and the time delay is 2 seconds. So for the first order transfer function and time delay, what is the general equation for the first order transfer function? Ni, first order transfer function with date time. So macam ni kita nak tulis first order transfer function equal to K E time minus T naught divided by
Time
tau S plus 1. Betul? Okay, so this is the general function for the first order reaction with time delay. Alright, so the gain is 1 E. Okay, T not referring to the time? Apa ni?
delay.
Yes, time delay. So time delay given in the question is 2 seconds. So minus 2 seconds. Betul tak? Okay, divide by tau. Tau is the time constant. Time constant given is 9.6 s plus 1. Okay, masukkan this transfer function into this block diagram. 1e minus 2s divided by 9.6s plus 1. So ni nanti masukkan dia punya unit apa input apa output dia masukkan nanti. Alright. And then disturbance. So kita pergi dekat disturbance. So disturbance, the information given for level controller, the inlet flow rate, the relation between the flow rate to the level in the column is represented by first order system. Alright, first order system with gain. Gain is given 5 cubic meter per hour divided by m, and the time constant is 7.5 seconds. So how do we write down the the control the transfer function for disturbance? So basically it is same with the process punya transfer function, first order transfer function, which is the K divided by tau S plus 1. So that is the transfer function for disturbance. So kita kena tulis the gain given is 5 divided by the time constant is 7.5 S plus 1. Okay, so this is how we draw a transfer function. Yeah, okay, sorry, this is how we draw a block diagram for the level controller. Okay, so yang ni masukkanlah dia punya ni MA per unit E MA. This one you can refer back to the notes MA, and then this one F kg per hour. Okay, this one you can refer to, you can refer back to the notes lah ya. The unit of each of the stream. Alright, now we move to, okay tak semua?
Ni kat lab dulu ya. Terima kasih semua.
Okay, terima kasih Dr. Liza.
Okay.
Okey tak? Semua okey tak? Faham
Okey,
Yang ni?
Okey.
Alright. Baru close suara. So yang ni masukkan ini salah ni dia punya tu. Alright. Okay, ni untuk temperature controller. So temperature controller sama juga. All the
Kak
info.
dulu ya.
Apa dia? Okey, terima kasih. Alright, for temperature controller, ada sesiapa nak cuba macam nak lukis block diagram? So for temperature controller, okay, this is the information that has been given. Okay, ni. This is the temperature controller, the information for the transmitter, for the controller, for the valve, and then for the process. For the process, and then for block diagram for temperature controller, we doesn't have the disturbance, so tak perlulah letak disturbance ni. Okay, boleh someone volunteer to draw temperature controller dalam notebook tu?
Madam, notebook tu tak ada lah untuk student punya.
Tak ada ke? Padahal awak senyap je. Asal tak bagi tahu? Masya Allah. Tak boleh
Tak boleh tak? Try access tak ada.
Tak ada Awak nampak, tapi awak nampak kan apa yang saya tulis ni kan?
Yang kat screen madam nampak lah.
Okey.
Semua
Saya
team
rasa
kami je lah tak ada.
tak ada Okey. Sepatutnya ada Sekejap. Saya pun tak ni. Ke review student work, bukan copy content, distribute ke macam ni? Alright, sekejap. Saya tutup dulu dia punya ni. Awak tak bagi tahu. Confident je saya. Sekejap, stop sharing. Okey, kat sini kan ada ni kan. Ada whiteboard kan? Kat whiteboard ni kot boleh okey. Kat sini boleh tak awak lukis? Boleh tak? Can anyone? Sesiapa? Cuba. Alright. So boleh Okay, boleh tolong share drawback for temperature controller? Okay, siapa yang nak tolong buat? Takut bertindih pula. Can anyone volunteer?
Boleh doktor? Saya volunteer.
Siapa ni? Iqmal bukan. Azrai. Okay, Azrai. Alright, Azrai?
Boleh.
Okay. So try to share your answer. Okay, so untuk temperature controller kita tak ada disturbance. The information we have is only on transmitter, controller, and then valve and also the process. Okay, so yang Azra tengah lukis ni transmitter kot Okay, transmitter. So transmitter given, the gain given is berapa? 0.08. Alright. Okay. Pas transmitter, don't forget to write down the unit sebab ni nanti akan akan dilihat juga nanti dalam final exam. Okay. Masuk ke dalam PID. PID is different with PI dia punya transfer function. For PID, the transfer function is apa PID? KC times 1 plus 1 over integral time S plus derivative time S. Tutup kurungan. Alright. 1 over integral time S. Please bear in mind time ni kena dalam second. So kalau dalam final exam dia bagi dalam minit, so you need to change to second. Okay? 1/7s. 7 is the integral time. And then plus derivative time is 10 second. Alright, time S tutup kurungan. So that is the transfer function for PID controller. So kena tengok jugalah dalam soalan sama ada dia nak PI controller atau dia nak PID controller atau P only controller. Kalau P only controller biasanya kita akan ada gain, dia akan bagi gain je, dia tak ada integral time, dia tak ada derivative time. Okay. And then PNID will send the information to the valve. So valve dia kata apa? First order transfer function juga kan? But this time we have time delay. Okay.
Tak muat ni.
Kecil sikit lah untuk ni. Untuk apa nama controller nanti. Azrai, ada negatif ke tidak?
Zoom out lah Azrai, nanti whiteboard kerja besar.
Betul-betul. Transfer function untuk valve tu ada negatif tak? Okay, minus 1.2s divided by ts plus 1. Okay, lepas dalam valve masuk ke dalam proses. So basically transfer function of the process ni akan menentukan what is the value of the P, I and D. Okay, so for the process ni no longer first order, untuk proses pun second order transfer function. Alright, so for second order transfer function KE with time delay minus S T naught. T naught is your time delay divided by tau square S square plus 2 damping ratio, time damping ratio time tau S plus 1. Kuasa 2. Kalau kuasa 2 masukkan terus. That's right. 20 the power 20 masuk 20 kuasa 2 berapa? 400 kan? Masukkan terus 400. 400 S square plus 2 time damping ratio time tau time S. Masukkan terus value dia. 2 darab damping ratio berapa? Darab tau berapa? Alright, 20S. Masukkan betul. Plus 1. So this is the second order transfer function. That's right. Untuk time delay tu ada minus tak? Okay, minus 5S. Alright, so just complete the closed loop. Keluar supaya kita tak ada disturbance, terus je. Alright, betul. Okay, so nanti masukkan dia punya formula tu unit. Degree C, T, bawah pun sama, bawah dia akan sebelum okay. Dekat bawah sebelum masuk transmitter unit TS. Dah
Dah.
Okay, unit tak masukkan saya completekan okay. T degree C. Alright, kemudian MA. So basically kat sini kalau boleh kita masukkan ni lah apa nama blok untuk ni apa padam sebelum ni kita masukkan dulu ni set point dia kan. C 0.08 and PR and then MA. Okay, kemudian ni akan measure the error, the unit is also in MA, and then this is our PID. Alright, the unit is MA. Okay, and then okay, keluar tu temperature and decreasing. This is kg per hour ni sebab steam tadi lah flow rate. Kita regulate flow rate of the steam. Alright, so good job. So this is how we draw a block diagram for temperature controller. Thank you Azrai. Thank you all. Ada soalan tak sebelum tu?
Doktor, saya nak tanya ni untuk yang lepas transmitter kan dia pakai milliamp kan? Lepas tu bila dia masuk dekat controller dia tu, dia guna percentage transmitter output. Boleh ke pakai milliamp sebelum dia masuk ke proses tu?
Sebelum masuk ke proses. Ni kan proses.
Controller.
Ni valve. Ni kita punya controller. Okay. Correct. Daripada ni, PID. PID masuk ke valve. Ya, masuk awak milliampere
Daripada transmitter masuk ke controller, silap-silap.
Controller masuk
Kat
transmitter.
sini.
Okay. Sebab kat sini akan ada kat sini controller will receive the electric signal daripada transmitter. Lepas PID tu baru dia convert biasanya, tapi kat sini kita tak tunjuk lah. Dari PID ke valve ni dia akan convert lah. Convert dia the electric signal to the pneumatic signal.
Oh, walaupun dia punya gain dia dalam percentage CO over percentage TO doktor. Oh,
so
faham.
sebab yang tu adalah the unit yang kita dah come out daripada calculation kan. Signal ni benda lain. Signal ni adalah nanti dia akan convert lah dalam di equipment itself, dia akan convert daripada milliamp dia nak electrical signal, pneumatic signal macam tu.
Oh.
Itu the unit transfer function ni dia tak reflect kepada unit sebenar unit sebenar cara equipment kita tu bekerja. Tak.
Oh, faham.
Sebab yang kat sini ni kita kita tunjuk unit untuk ni lah, unit untuk unit untuk dekat mana dia bekerja. Dia masuk dalam degree C, dia keluar tu kepada electrical signal. Okay.
Okay.
Right.
Thank you doktor.
Doktor, saya nak tanya berkenaan mini project. Dia kata minimum 8 pages. Lepas tu dia kata pula no extra pages. Maksudnya memang report nanti just bagi 8 pages sahaja lah kan?
Ya betul. Sebab kalau kita tak limit awak punya pages, nanti pages awak akan jadi 20-30 pages, which is we try to avoid that amount of pages. So biasanya kalau kan kamu kena tulis dalam manuscript form kan, bila manuscript form dia ada 2 column. I'm sure you can fit all the information into the manuscript in 8 pages. Mesti boleh punya. Cara dia sebenarnya sama juga macam journal. Awak kena belajar untuk extract the key important statement daripada apa yang awak buat tu masuk ke dalam manuscript. Sama macam awak nak buat journal nanti. Journal awak ada banyak information, awak ada banyak statement kan. So macam mana cara awak nak extract the important statement, the important statement and information yang perlu masuk dalam manuscript. So macam sample of calculation, kalau berulang tak perlu tunjuk dalam manuscript. Cakap je awak letak the information dalam appendix. Appendix tak dikira, appendix awak nak buat 100 pages pun boleh. Tapi the body of the thesis or manuscript itself kita limit kepada 8 pages saja. Untuk mengelakkan kita tulis merapu-rapu jugalah. Macam tu. That is the function.
Alright, faham madam.
Okay.
Untuk submission due date and time tu week 14, hari apa tu be exact?
Week 14, lab report awak hari apa? Sepatutnya lab hari apa?
Hari Khamis tak silap. Khamis ke Rabu?
Rabu.
Rabu.
Rabu. Okey. Kejap tentang due date ni pun saya nak kena remind kat awak sekejap. Okey ke on block diagram ni? Sebab saya ada okey? Okey. Alright, saya tutup dulu. Stop presenting. Sekejap. Saya tengok balik tarikh dia tu. Sebab kita tak guna pakai week 14, week 11, week 12 tu semua kita tak pakai. Tapi kita berpandukan balik pada berpandukan balik pada tarikh-tarikh yang diberi. Okey, kejap cari jap. Boleh nampak tak? Alright. So sepatutnya minggu ni adalah minggu 11 ikut kiraan kita, tapi
Madam, tak nampak.
Tak nampak ke? Dah.
Kena stop sharing whiteboard dulu kot.
Saya letak whiteboard. Saya memang letak dekat whiteboard.
Oh, kat whiteboard. Okey, baik.
Ni. Nampak tak? Yang lain nampak tak?
Nampak.
Nampak okey. So kita tak guna pakai week 13 week tu, kita balik semula kepada awak punya tarikh. Contoh lab test kan. Lab test 17 hingga 21. Sepatutnya minggu depan adalah week 13. Asalnya kan. Tapi bila kita dah drag masa semua tu, so minggu depan jadi week 12. So week 13, 14 tu tak boleh guna pakai lah. Awak berpandukan tarikh. So awak punya lab test adalah sama ada week 13 atau 14. Setuju tak kalau kita nak buat minggu depan atau minggu satu lagi? Tapi minggu satu lagi ada ada quiz. So saya rasa better this week lah kita not this week, not next week kita akan buat lab test. Alright, kemudian week 14 kita akan ada quiz. Week 14 ni adalah 24 hingga 28 Januari. Quiz, kemudian submit mini project adalah pada 31 Januari hingga 4 Februari. Sebab week 14 yang kalau ikut kiraan kita sekarang ni adalah sepatutnya study leave kan. Study leave tu pula kalau tengok balik pada kalender, kita akan ada cuti, berbagai jenis cuti, betul tak? Isnin Selasa tu cuti raya Cina ke Taipusam?
Taipusam tak silap saya.
Cuti kan Isnin Selasa tu kan. Sebab tu lah kalau boleh kita tak kacau lah study week tu. Okey tak? So minggu depan kita akan ada lab test. Minggu satu lagi akan ada quiz. Kemudian awak punya submission of mini project start daripada 31 Januari hingga 4 Februari. So sebab saya baik hati, saya bagi awak last submit 4 Februari. Okey tak? Before 6 PM. No more extension. No more extension, okay?
Okay.
Alright.
Okay, saya bagi tarikh akhir tu lah 4 Februari sebelum 6 PM. Deal?
Deal.
Alright, good. No more extension. Promise?
Okay.
Okay, alright. Okay, so tu je lah announcement untuk hari ni. Minggu depan.
Madam. Soalan lab test tu dia macam mana?
Objektif. Apa yang awak dah buat, apa yang awak dah buat dalam lab tu dia akan tanyalah. Mungkin dia akan tanya mungkin dia akan tanya apa feedback controller, apa nak guna PID ke, mungkin macam tu, saya pun tak tahu soalan dia. Tapi objektif lah, MCQ. Okay, ni MCQ. Alright, kemudian kita ada 15 question. And then kenapa macam ni? Okay, sekejap. Sorry, ni MCQ. Kita ada 15 question. Duration adalah 45 minutes. Kemudian test ni akan dibuka selama 24 hour. Kalau kamu start 8 AM Wednesday sampai 8 AM Thursday. This one only one attempt. Clear?
Clear, Doktor?
Clear, Madam.
Alright, good. So itu je, kalau tak ada apa-apa, takut depan ni awak ada kelas kan? Pukul 9. Dah 8.59 dah ni. So kalau tak ada apa-apa, tu je. Thank you. Assalamualaikum warahmatullahi wabarakatuh. See you next week.
Waalaikumsalam. Thank you, Madam.
Thank you.
Okay, okay.
Thank you.
Alright. Okay.
Madam.